Today, we're going to be learning gas stoichiometry, which combines stoichiometry, which you know from previous unit, and the gas laws, PV equals nRT. So I'm going to give you a moment to copy down this problem. So let's go over what this problem is asking. We have an equation, and then the problem says, what volume of NH3 gas, so here, measured at this temperature and this pressure will be needed to produce 5,000 grams of this product. Now, normally, before this unit, what we would do is we would start with the 5,000 grams of the product. We would turn that into moles, and then we would just use our molar ratio of 1 to 2 to get over to the moles of ammonia. Right? And then we would say like, oh, okay, you need grams, and we would switch to grams of ammonia. But the problem here is this is a gas, and we want the volume of that gas. And as we've learned, unless you're at STP, we need to use PV equals nRT to find the volume of a gas. Now, if you're at STP, you can use 22.4 liters for every mole of a gas. But if you're not at STP, then you have to use PV equals nRT to find the volume of the gas. Is everybody following me? Great. So what we're going to do is we're going to treat this like a regular stoichiometry problem. We're going to take our 5,000 grams of our product. We're going to go from grams to moles. Then we're going to go from moles to moles. Once we have moles of ammonia, we're going to use the moles, the temperature, and the pressure, and we're going to plug all that into PV equals nRT, and we're going to find the volume. Good? Okay. So let's start. So I've already calculated the molar mass of the ammonium sulfate because we need that to convert our grams to moles. All right, so there's a little bit of a refresher course on the stoichiometry, huh? Yeah. So here we're going to start. Do I have a better pencil? No. Okay. So 5.00 times 10 to the third grams of ammonium sulfate. Now I want to go from here over to moles. So 132.17 grams of ammonium sulfate to 1 mole of ammonium sulfate. And then we're just going to use our molar mass to get back over to the ammonia. Our molar ratio. So 1 mole of the ammonium sulfate to 2 moles of ammonia. That's it. We're done. We have our moles. So when we do this, we get 7.57 times 10 to the 1 moles of ammonia. And that's a lot of ammonia. It is 75.7 moles, but we did start with a huge amount of ammonium sulfate. 5,000 grams. That's a lot, right? Okay. So now what we want to do is we want to take these moles of ammonia, by the way, gas, and we're going to figure out the volume of that. And since it's not at STP, we have to use PV equals nRT. So let's look and see what we have. We have pressure, which is equal to 1.66 ATMs. We have temperature, right, which is equal to 78 degrees Celsius, which is 351 Kelvin. We have N, which we just calculated, which is 7.57 moles of NH3. And what we're looking for is volume. So now this should start to look really familiar because this is this unit, right? So now I'm going to take my PV equals nRT, And I'm going to solve for volume, which is nRT over pressure. And now I'm ready to plug in. So volume is equal to 7.57 times 10 to the 1 moles times R, 0.0821. Glad I'm riding a camel. And temperature, 351 Kelvin. And all of that is over 1.66 ATM. I cancel out ATM, I cancel out moles, and I cancel out Kelvin, and I'm left with liters, which is great because I'm looking for volume. So my volume is equal to, when I run my math here, 1.3 times 10 to the third liters. Now that seems like an awful lot, 1,300 liters, all right? So, that's a lot. Am I concerned? A little bit. So let's go back and double check our numbers just real quick, because 1,300 liters seems like a lot. So I go back and I look, 1,300, but 75.7 moles, that's kind of a lot too. Let's go back even farther. Oh, wait, 5,000 grams. I want to produce 5,000 grams of ammonium sulfate. So if I want to produce that much ammonium sulfate, I'm probably going to need to start with a whole lot of ammonia, right? I mean, I can't start with okay, you're going to start with 2.6 moles of ammonia and you're going to produce 5,000 grams. Nope, that's not going to happen, is it? No, it's not. So probably 1.3 times 10 to the third liters. Yeah, that's probably pretty reasonable to produce 5,000 grams. Yep, we're probably talking thousands, right? Okay, we're good to go. Not unreasonable. Okay? Questions? Okay, one more repeat on the process. We started with the grams of ammonium sulfate. We went to moles of ammonia. We looked at our conditions and we plugged our moles of ammonia into PV equals nRT, which gave us the volume of the ammonia. And that's what they asked. What volume of ammonia? All right? Okay, so now we're going to do a problem. You're going to do it at your seat, and I'm going to do it up here silently, okay? All right. So first, let's go over the problem, the givens. Here is the formula. 2 aluminums solid plus 6 HCl aqueous yields 2 aluminum chlorides aqueous plus 3 H2 gas. I'm going to give you a minute to copy the equation, and then I'll go over it. All right, now let's look at the givens. So in this problem, 4.25 grams of solid aluminum is going to react, and it's going to produce hydrogen gas. Okay, that hydrogen gas is going to be at 15 degrees Celsius and 94.4 kPa. The question is, what is the volume of that hydrogen gas? This is the same problem. It's just that you're not looking for the volume of the reactant. You're looking for the volume of the product. Same problem as the last one. Okay? All right. So I'm going to be working up here silently. You're going to be working at your seats. You can look up as often as you want or not look up at all until you get to a stopping point or until you get to the answer, and then look up and check my work. All right? Okay, let's get started. So question arose, what is this information? So you are given 4.25 grams of aluminum, and you're reacting that 4.25 grams of aluminum, and the product that you're getting is hydrogen gas. That hydrogen gas is at 15 degrees Celsius and 94.4 kPa. And And what I want to know is what is the volume of that hydrogen gas, okay? All right, so here we go.